Hello guys, and welcome back to Introduction to Number Theory. You see a continued fraction. Well, it is a specific manner of writing down continued fractions. First, we will write the continued fraction itself as a fraction of many floors, with many floors, and then we will find the value of this fraction. Well, let's start. Here we see that almost all of the separating signs are just commas. But here we have a comma with a dot. This means that the first number is the integer part of the continued fraction. So this is equal to 1 plus 1 over 24 plus 1 over 2 plus 1 over 1, and these fractions get so smaller and smaller. 22, 2, 1, 1 more time 1, plus 1 over 2, and finally plus 1 over 5. So we have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, so this is the continued fraction that is just not to draw fractions with many floors. We can write in one row using the brackets of this type. Okay, what if we try to calculate the value of this fraction? Where do we begin? We can, of course, try to do something in the beginning of the fraction, but it is not quite convenient. At the same time, at the end of the fraction, we can say turn the last, no, not the last, but the denominator before the last denominator into an ordinary fraction. So we can say that this is just 2 times 5 is 10, so this is 10 plus 1, 11 over 5. And then we can turn 1 over this 11 over 5 into 5 over 11. Then take the next number we have inside the continued fraction, so 1 plus 5 over 11, and turn it into 1 plus 5 over 11, it is 16 over 5, right? No, 16 over 11. And then take this, and then take this 1 over all this and say that it is equal to 11 over 16. And continuing this way, we can calculate the value of this continued fraction, but let's just rewrite the fraction using this conclusion here. So it is equal to 1 plus, nothing changed here, so it's 1 over 24 plus 1 over 2 plus, well, 1 over 1 and plus 11 over 16. So instead of 1, 2, 3, 4, 5, 6, 7 floors, now we have 1, 2, 3, 4, 5. Well, okay, we somehow managed to defeat 2 floors. We go on with our procedure. And now turn this into 16 plus 11 is 27 over 16. Over 16. This means that this is equal to 16 over 27. And when we add 2, we will have 2 plus 16 over 27. 2 times 27 is 54, plus 16, it's 70 over 27. And now we are here, so let's rewrite this fraction one more time. Well, here we have 1 over 70 over 27, so we can just simply write 27 over 70. So we continue. (24) plus 27 over 70. This is equal to, well, we need to multiply 24 by 70. And I'm afraid I will use my calculator at this point. So 24 multiplied by 70 is equal to 1,680. So this is equal to 100, just add 27. This is equal to 1,707 over 70. And then we turn this big fraction into 70 over 1,707. And finally, we add 1 to this fraction and we gain well, 1 plus 1 multiplied by 1,707 and plus 70 is equal to 1,777 over 1,707. And this is a rational number. In the beginning, we took a continued fraction, a finite continued fraction. And starting from its end, we rolled up this fraction until we gained just an ordinary fraction, integer divided by integer. Acting similarly, we understand that any finite continued fraction represents a rational number. So we can even write this down. We have a finite continued fraction, a0 plus 1 over a1 plus 1 over a2 plus and so on. And it ends at some moment plus 1 over an. So every such fraction is equal to a certain rational number. Further on, we will see about infinite continued fractions. We will prove that infinite continued fractions also have values, and these values are obviously irrational. But now I have a question for you, which I will not answer in this video. Please find out what is so special about numbers 1777 and 1707. See you in the next video.